All right, so this assignment was about solving rational equations with unlike denominators. Um, so again, we have options here. You can get a common denominator and subtract to make it one fraction on the left side and then cross multiply. But another method that we're going to use here in this class is just clearing the denominator. So we have 3x, 6, and a 6x. So the first thing you have to do is identify what is the least common denominator going to be. And so you can see between just the numbers 3, 6, and 6, it's 6. And then x is the variable. So our least common denominator is 6x. So what we're going to want to do in this problem is we are going to want to multiply both sides by 6x. All right, and then so what this does means I've got to distribute it on this side. All right, and so I'm going to end up with 6x over 3x minus 6x over 6 equals 6x over 6x. And then we can simplify each of these fractions and the denominators will go away. So it's just going to be 2x here, or just 2, excuse me, 6x over 3x is 2. 6x divided by 6 is just x. And then this is just 1. So you can see all the denominators went away, all right, because we just simplified each fraction. Again, 6x divided by 3x is 2. Right, 6x divided by 6 is x. 6x divided by 6x is 1. I no longer have any denominator, so now it's just a linear equation to solve. Again, and that's always going to happen. If you multiply both sides by the least common denominator, or any common denominator really, the bottoms will end up, after you distribute and simplify, the denominators will go away. It's called clearing the denominators. So now you just solve, subtract 2 from both sides. You get negative x equals negative 1. Divide both sides by negative 1, so x equals positive 1. All right. Next example. And remember, always a good idea to make sure you're sending yourself notes. Okay, so you always have them there. Next problem. Okay, so again, what's the least common denominator going to be? The least common denominator is going to be 3x squared. All right, so I'm going to multiply both sides by 3x squared. Left side and the right side. And I'm going to multiply. So now I'm going to distribute that on this side. Right? And so you end up with 3x squared over x equals 12x squared over 3x squared and plus 3x squared over 3x. So again, now when I simplify each fraction, the denominator is going to go away. So over here, 3x squared divided by x is just 3x. And then 12 divided by 3 is 4. Which is squared. X squared divided by x squared goes away. And then 3x squared divided by 3x is just x. Subtract x from both sides. I get 2x equals 4. Divide by 2, x equals 2. All right, and again, I didn't check for extraneous solutions on the last one or this one, just because the only thing that would, if it's 0, that's the only thing that could be extraneous, and my answer is not 0. All right, so now we notice that everything's going away, and what are we left with here is we're just left with on this side 3x, right? So I'm going to show in this example here maybe something that's a little bit different here. Okay, so if I factor the denominator, all right, so sometimes you need to do this, to see the common denominator. Sometimes the common denominator is hard to recognize, so sometimes you want to factor the denominator first, right? So I could take out a GCF of x on that one. Okay, that one, there's nothing to factor out. And so now if you look, right, all three denominators have an x plus 5 in it, right? The first one and the last one have an x. This middle one is missing an x, all right? So another way to clear the denominator, instead of multiplying both sides by that, is just creating everything to have that common denominator. So what I'm going to do is kind of just multiply this one by x over x, right, to get that common denominator of x times x plus 5. And now, once all the denominators are the same, what did we learn in the last class was that they just all cancel out. So when you multiply both sides by the common denominator, they cancel out. So all I have is the top here. So just make sure you multiply, okay, this x times that. So you get 6 plus x equals 5. All right, and now you get subtract 6 and you get x equals -1. All right, and again, it's not a 0 or a -5, so it's not extraneous. All right. So over here on this one, all right, if I factor the x squared minus 4, that's the difference of 2 squares, so that's just going to be x plus 2, x minus 2. All right, and then, so this one has an x minus 2, so it's missing an x plus 2. Right, so I'm just going to multiply the top and bottom by x plus 2 on this one. And on this one is missing an x minus 2, so this one I'm going to multiply by x minus 2. And again, you're doing it on top and bottom. I'm just showing the top right now because that's going to all cancel out anyways. The trick on this one is make sure you distribute this negative sign. So it's x squared, and then it's -1 times x plus 2. So it's negative x minus 2 equals x minus 2. So now I have a quadratic that I need to solve. So when I'm solving a quadratic, we want to set it equal to 0. So I'm going to subtract x from both sides. I'm going to add 2 to both sides, right? Subtract x, add 2. And that becomes 0, right? And then I get x squared minus 2x equals 0. And so solve that, factor out the GCF. I get two answers. And those answers are 0 and 2. Oops. All right, now if I look back at the original problem, right, any of those answers make the denominator 0, and 2 does. Okay, 2 minus 2 is 0. So this is an extraneous solution. So the only correct answer on this one is x equals 0. All right, fifth example here. All right, I got this quadratic trinomial. I got a linear binomial. So maybe this one's hard to see what that the least common denominator is. So if I factor this, I'm going to see that it's x plus 3. Change my color here, make it a little skinnier. So x plus 3, x minus 4. And so now you can see that this first fraction here, 1 over x plus 3, is missing the x minus 4. And then this one is missing the x plus 3. Again, I'm writing on top and bottom, okay? But I know it's going to cancel out, so I'm just not going to waste my time writing it on bottom. All right, so I get 6 equals, and again, this is just 1, but normally whatever this number is, or it could be even a variable, you would distribute it. So that's just x minus 4. And then again, this one's 1 as well, so just distribute that one. So that's x plus 3. And then combine like terms. So x plus x is 2x. Negative 4 plus 3 is negative 1. Add 1 to both sides. You get 7 equals 2 over x. So x equals 7 over 2, or 3.5. And that's not extraneous, right? The only thing that would have been extraneous was negative 3 and positive 4. So good. All right, last example. All right, so again, same as last time, I'm going to factor the quadratic trinomial to be k minus 3, k plus 1. Oops. All right, so you can see that this one's just missing the k plus 1. And that's missing both. This one's missing both of them. All right, so what I'm going to do is I'm just going to write it as the standard form because I'm going to end up having to multiply it together anyways. So it's missing the k squared minus 2k minus 3. All right, and so on the left side, that's what I'm going to have. K squared minus 2k minus 3 equals, again, I'm just canceling out all the bottoms here. So 1 plus, and now I've got to distribute this 2k. So it's 2k squared plus 2k. And now I've got a quadratic again. So I'm going to just subtract everything over. So I'm going to subtract this over here. I'm going to add 2k to both sides. And I'm going to add 3 to both sides. Right, so that way the left side of the equation is 0. And if I put it in standard form, 2k squared minus k squared is k squared. 2k plus 2k is 4k. And 1 plus 3 is 4. So I could factor this. All right, so that's just k plus 2 squared. So my answer is k equals negative 2. And that's the examples.